we can use the parabola construction to construct square roots. For instance, I want to figure out the square root of 7, or construct a line segment that's length is the square root of 7. Well, the first thing I want to remind you about is if I have a parabola like y equals 2x squared, and I have a point on it like 318, I want to remind you that the slope, to get the slope of a polynomial equation like this, you multiply the exponent times the coefficient, becomes 4, and you subtract 1 from the exponent. So that means the slope of the tangent line, that is, in this case, is 4 times 3 to the first equals 12. So you can get the slope of that. So this equation is y equals 12x plus b. Now, to get the y-intercept, one way of doing that would be to plug 0 in for x. So, plug 0 in for x and plug 3 and 18 in for y, and we'll get the b value. So 18 equals 12 times 3 plus b. 18 equals 36 plus b. b equals negative 18. So the intercept is 0, negative 18. Notice that this negative 18 is the opposite of the 18 there. That is not a coincidence. Here's another example. Y equals 1/4 x squared. It has on it the points, just to make one up, 2, 1. Here's the tangent line. The slope is 2 times 1/4, so it's 1/2 x to the 1, or in this case, since the x coordinate is 2, 1/2 times 2, which equals 1. The equation of this tangent line is y equals 1x plus b, and if you plug 2, 1 in as the other point, we'll get the y-intercept. So 1 equals 1 times 2 plus b, or b equals negative 1, 0, negative 1. Notice again, the y-intercept was the opposite of this. And that is generally going to be true. So if I were to give you any parabola and say that this point was 5, 19 for whatever reason, then this point here would be 0, negative 19. Now, to make y equals the square root of 7, the idea is going to be the parabola y equals 1/4 x squared has on it the point square root of 7, 7/4. You put square root of 7 in for x, and that would happen. So that tangent line would have 0, negative 7/4 as its y-intercept. And from before, from the last video, the parabola y equals 1/4 x squared, 1/4 is 1 over 4p equals 1/4, so p equals 1 means the focus is at 0, 1, and the directrix is at y equals negative 1. So if our goal is to find this point, all we would have to do is take the point 0, 1, the point y equals negative 1, the line, and the point y 0, negative 7 over 4. This is how I'm going to get the square root of 7. And to get the square root of 11, it would be negative 11 over 4. Over here, down here. Now we're going to fold we want to create that tangent line. And the tangent line has to go through here. So we use axiom 5. We're going to fold 0, 1 onto y equals 1 in such a way that that fold passes through this point. So we fold 0, 1 to somewhere, in this vicinity, so that it creates this fold. So I folded. This is basically my P point. This is my Q point, and this is my L point, my L line. So fold 0, 1 onto the directrix so that it passes through Q. That creates the tangent line I wanted. But I also want to have the this line is the tangent line. It's this guy. But I want this actual point. So to do that, I have to know where P got folded onto. So if I make another fold, this time I fold this line, which I could draw in, onto itself so that it goes through this point. So here's my other fold. This point here was the point that P was folded onto, and that means that this point up here is the point square root of 7, 7/4, which means that this line segment is the square root of 7, or even easier, once we find this point here, this will be the square root of 7. So with that, we're able to use the parabola construction to create a line segment whose length is the square root of 7. You always use 0, 1 as the focus, and y equals -1 as the directrix, and 0, negative, whatever square root you're trying to get, over 4 as your Q point, the one that the fold has to go through.